Okay guys, back at it here one more time. I know we skipped a section last time, so we're going to back up and catch that last section. We were wanting to figure dose rate at the capsule. We skipped over that section. There's about 5 of those problems. So here's what we're going to do. If we consider the source, okay, I always draw it like this, it just helps me get a little visual. And then we're standing out here one foot away, then we know we're catching a lot of dose from this source right here. Let's just say it's 100 curies of iridium. 1 foot away, we know that is a big dose. But we know it's an even bigger dose as we get closer to it. So we want to figure just on the outside source or out on the outside surface of that capsule what a value would be. So we're going to go back to this right here. The only thing that's going to change is instead of having an intensity 1, intensity 2, that's all going to be the same. Our distance 2 squared and our distance 1 squared are now a little different. Okay? Instead of having 1 foot squared, okay, we know it's 1 foot squared and it's still the same thing. It's now going to be 12 inches squared. Okay? Because we've got to convert to something that we're very familiar with. So if we're converting to inches, we're going to go here. Okay? It says in your directions that the capsule source or the source is considered to be at 0.1 inches. Okay, so 0.1 squared. Got a couple things to figure out. First question says something to the effect of calculate the dose at the surface of the capsule containing 70 curies of cobalt-60. So 70 curies cobalt-60. Okay? Simple enough. 70 times 14 gives us a value of, I left my calculator over here. Tend to do that from time to time. 70 times 14 is 980 Rankine per hour. Oops, let's get rid of that. 980 Rankine per hour. So that would say, instead of 100 curies of iridium, we're going to say 70 curies cobalt. Standing right here, yeah, we're really saying oh crap, because that's 980 Rankines per hour at 1 foot. So we know it's just going to get stronger and stronger and stronger back to the source. So plug in our number right here, 980. Okay, we don't need to change it. Rankine is fine. And we're looking for intensity 2. 980 times 12 squared. Okay, that value is, if my calculator is correct, which I'm going to say, or I'm going to hope it is, I've got a line out of my calculator, 141,120, okay, just a number. Now we're going to divide that by 0.1 squared, and that's going to bring us to 14112,000. Put a couple commas in there. That's still Rankines per hour. Okay? Now this is the value at the surface of that capsule. So if we were standing right on top of it, it'd be 14 million Rankine per hour going into your little foot there. Might be kind of painful. So not a good thing. Okay? Then we've got one more section, but I'm going to show that in another video. One more section over shielding and distance. I'm going to write out a big problem, and then I'm going to keep all this stuff up here, but write out a big problem so we can use that. Okay?